Hello again, second partition example. All right, so here we have a partition of the int of, or not necessarily a partition, we haven't determined that yet, but we have, sorry about that. We have a collection of sets, and we want to see if that's a partition of the integers. Now this might be something you haven't, maybe you weren't aware of, but in any case, so let's I guess like we did the last one, let's write out some of the, so let's see, a sub 0. Now there's an ai, the I here, there's an, so I is in z, so there's going to be an a0, an a1, an a2, so on. There's also an a negative 1, an a negative 2, and so on. Okay. Let's look at some of those. I guess we'll do a negative 2. That's just the set containing negative 2. A negative 1 is the set containing negative 1. A 0 is the set containing 0. A1 is the set containing 1. And let's see, A2 is the set containing 2. There's many more in both directions, into the negative and into the positive. All right, so let's decide if, so now let's see, first of all, looking at this condition, are each of those a subset of the integers? Yes, that's true. Are each of those non-empty? Yes, that's true. Let's see, what about the intersection? Do any of these sets have something in common? That's right, no they don't. And what about when you union them together? When you union them together, you get A back. So it meets all the conditions of a partition, and so then we have this here. All right, now I have to admit this is really one of the most boring partitions out there, but it's good to see this example because this shows that you can make a partition pretty much, you can make a really boring partition, one that isn't very useful, but is in fact a partition out of pretty much any set. Let's see, if you have some set, right, say A is, I don't know, alpha, beta, gamma, A, X. Then a partition of A is to just put everything in a single set.